For number 11, we're going to do a right triangle similarity question. So the key to this one is to be able to get everything to be facing the same direction. So usually we redraw here. So let's see, determine a state to the nearest 10, the length of RQ. So I'm going to keep my little triangle facing the same exact way. So I got T, Q, P. And the only thing that I could possibly have here is I could maybe have that TQ was really 17 minus X. So we'll see if that comes into play. So if I take my medium triangle, that would be P, Q, R. I have an X and a 15. And then in my big triangle, if I redrew that, I would have a T, a P, and an R. And I have a 17 and a 15. So if we look, you could have used Pythagorean theorem to get PT if you'd like out of that big triangle, but we don't actually have to, because what we have is we have a setup that works for us already. So we're 15 over X equals 17 over 15. We cross multiply, we get 17X equals 225. We'll divide both sides by 17. And I should know right away that it's probably going to work out to be a bad decimal because it told us to round. So to the nearest tenth, we get X is 13.2. So again, that problem solely works off the fact that you have them redrawn in the same direction. Triangle ABC is shown below. Construct the dilation of ABC centered at B with a scale factor of 2. So usually we do these by taking from our center of dilation, and we take our ruler and we extend the sides going out past those 2 points. And the reason we do that is because we are then going to take our compass and we're going to measure. So scale factor of 2 means that we have 2 slash marks. So there's our first one, scale factor 1, scale factor 2. So when we come down, we go back to B here, stretch it out. So scale factor 1, scale factor 2. So now we're going to connect this to finish off our triangle so that we actually have an image triangle. So we'll call that, for simplicity purposes, this will be A prime and C prime. So there's our dilation, and it says, why is the image ABC similar to the original triangle? So remember, when you dilate things, you end up with your corresponding sides being parallel. So then what you end up with is you end up with a bunch of corresponding angles. So they're similar by angle, since corresponding sides in a dilation are parallel. There are 2 sets of congruent corresponding angles. Okay, you could also talk about how your scale factors made everything in proportion. You could talk about a side angle side or a side side side. You could also work with your reflexive angle at B, but you do want to make sure you state one of your patterns. So I stated my angle pattern, and I said since dilation forms parallel corresponding sides, we had 2 sets of corresponding angles, and there was our angle.